Question number 62. We have a combination of conservation of energy and conservation of momentum in this problem. Frictionless track, thank you very much. Block M1 starts from the height of 5 meters. Remember, we only care about the vertical part because there is no friction. This length does not really make any difference. It has gravitational potential energy to begin with. That gravitational potential energy turns into kinetic over here right before the collision. Then it makes a head-on elastic collision with that second block. Remember, elastic collision means that approach velocity equals separation velocity. Calculate the maximum height to which M1 arises after the collision. UG equals K for the little M1. Initial, final, M1, M1. Then, so M1 G H initial equals M1 V1 final squared over 2. So your V1 final right before the collision, that's not after the collision, it's right before the collision, will be equal to 2GH initial, and it's going to be a root, which will give us the square of 19.6 times 5. That's 9.9 meters per second. So right before the collision, M2 is at rest, meaning that approach velocity is 9.9 meters per second. Conservation of momentum tells us one equation, two variables, unsolvable. Approach separation rule, I'm going to say 9.9 should be equal to, 9.9 is to the right, so I'm going to say V final 2 minus V final 1. I'm after V final 1, so I'm going to express V final 2, then plug this instead of V final 2. That gets me 9.9 M1 equal to M1 V final 1 plus M2 times 9.9, and then plus M2 times V final 1. 9.9 times M1 minus M2 divided by the sum of masses. M1 plus M2, that will be equal to my V final 1, which I'm after right now. So it's going to be negative 3.3 meters per second. So our block 1 bounces back with 3.3 meters per second to the left. And then to what height will it rise? Well, then you go your mgh final will be equal to m negative 3.3 squared over 2. Cancel your masses again. And then your h final is just going to be 3.3 squared over 19.6. I got 0.55 meters